Bismillahirrahmanirrahim. My name is Muhammad Adambari bin Yusuf Paliza. I am acting as the general manager for this project for this company. Next.
Next is my name is Muhammad Ozi bin Nasri. I will act as technologist one. Okay, next.
My name is Ismail bin Hussein. So
Okay, guys. First of all, can one of you can explain to me about what is uh, power flow analysis?
so the power flow from the assignment, a major problem with power system operation is limited capacity of the transmission system. Lens or transformer have limits, usually thermal, no direct way control, flow down transmission line. Example, there are no valve to close the limit flow. And open transmission system associated with industry restructuring is stressing the system in new ways. So we need to directly control transmission line flow by changing the generator output. So there is three type three method power flow. First is prime mover and excitation control of generation, control of tap changing and regulation transformer, and switching of shunt capacitor banks, shunt reactors, and static VAR system. So the first decompile power flow method is a very fast and efficient method of obtaining power flow problem solution. In this method, both the speed as well as the sparsity are exploited. This is actually an extension of method formula in polar coordinate with curtain approximation, which result into a fast algorithm for power flow solution. This method exploit the property of the power system where megawatt flow voltage angle and megavar flow voltage magnitude are loosely coupled. In other words, a small changing in the magnitude of the bus voltage does not affect the real power flow at the bus, and similarly, a small change in phase angle of the bus voltage has hardly any effect on reactive power flow.
Um, for this project, what type of method to study this power analysis problem?
Alright. I will explain our method to study this power flow analysis. Uh, I'm using the Newton method. Newton method, also known as the Newton-Raphson method, named after Isaac Newton and Joseph Raphson, is a root finding algorithm which produces successfully better information to root or real value function. The most basic version start with single variable of function defined for a real variable. The function derivative and initial guess for a root of function. In the function specified sufficient assumption and the initial guess is close, then is better approximation of the root than x0. Geometrically is the intersection of the x-axis and the tangent of graph of function at x0, f x0. That is improved grace in the unique route of the linear approximation at the initial point. The idea is to start with initial guess which is reasonable close to the true root, then the approximate the function by its tangent line using calculus, and finally to compute the intercept of this tangent line by elementary algebra. This x-intercept will typically be a better approximation to the original function root than the first guess, and the method can be iterated. Start the process with some arbitrary initial value. The method will usually converge provide this initial guess is close enough to the unknown zero. Furthermore, the zero multiplicity 1. The, the convergence is at least quadratic in a neighborhood of the zero, which intuitively means that number of correct digit rough double in every step. More detail can be found in illustration. This method is powerful technique in general coverage quadratic as the method covers on the root. The difference between the root and the approximation is squared at each step. However, there are some difficulties with the method. Right. That's all for me for explain the method, the Newton-Raphson method.
Okay, so what is the suggestion to improve this project power flow? Any
Oh,
ideas?
all right. So as I study after I study with the Newton method, I suggest the best way is using operation of UPSC. Is that's mean in unified power flow control. It's a series inverter used for active and reactive line power flow. Shunt inverter used for voltage regulation. UPFC is intensively used in power system because of their ability to provide flexible flow power controller. It's also used as a bank capacitor.
Okay, thank you. So um, I have done already the simulation. So let us see the simulation.
Yeah.
Okay, this is the first simulation without the capacitor bank as our technologists explain to us. So we play this. Okay, okay. As we see, we we receive only 0.834 pu or 287.66 kilovolt of uh, voltage power to us, which is not acceptable. So I have um, connected in parallel the capacitor bank. So as we see, uh, the PU is increased from 0.8 834 to 0.9676. So it's in the acceptable range. So, and we get 336.62 kilovolt of voltage, an increase of 48.96 kilovolts. So uh, we have ample energy to supply to our project. So we have after this no what we say no problem after this expansion in term of power into the factory or something, whatever. Okay,
Alright.
so I think that's it.
Alright.
Okay, I shut off this simulation. Okay, so any question?
No, sir.
Okay, so we end this meeting. So thank you.
Alright. Thank you.
Yes, thank you.